into Chapter 10, the mole. Okay, in this chapter there are 5 sections, and we will be doing all 5 sections. Section 1, measuring matter. Our objectives: explain how a mole is used to indirectly count the number of particles of matter, relate the mole to common everyday counting units, and convert between moles and the number of representative particles. Review vocabulary. Remember that a molecule is 2 or more different atoms that are covalently bonded together to form a unit. The new vocab we're going to be looking at is the word mole and Avogadro's number. Main idea for this section: chemists use the mole to count numbers of atoms, numbers of molecules, ions, formula units. Okay, remember in chemistry that when we're talking particles, when we're talking substances, when we're talking molecules or atoms or any of those things, they're very, very, very small. So we need a way of counting such small items. Okay, so we need a method to convert the amount of number of atoms, molecules, and formulas into something that we can actually use. So they have come up with this definition of the mole. The mole is an SI base unit used to measure a specific amount of substance. Now, 1 mole, they have done lots of research and found that 1 mole is the amount of atoms in 12 grams of pure carbon-12. Okay, that's the one that's listed on your periodic table. And we know that that is 6.02 times 10 to the 23rd atoms. We call this number Avogadro's number because he is the scientist that did all the research to come up with that number. Okay, now we're going to use that number to be able to convert between factors. First one we're going to try is moles to particles. So we know that we have 6.02 times 10 to the 23rd. Okay, that is Avogadro's number. This particles right here, we can change this to atoms as we saw it before. It can be molecules, it can be ions, it can be formula units. So in our conversion factor for moles to particles, we know that we have 6.02 times 10 to the 23rd particles for every mole. So if you are given 3.5 moles of sucrose, how many particles do we have? You always start with what you're given on the left-hand side, and then you're going to multiply through by your conversion factor. So what you're given, 3.05 moles of sucrose, times your conversion factor, 6.02 times 10 to the 23rd molecules, over 1 mole of sucrose equals 2.11 times 10 to the 24th molecules. So your answer, this would be your answer. Same principle in going from particles to molecules. Okay, you're going to use the inverse, however. We're still going to use Avogadro's number. So we know that 1 mole is 6.02 times 10 to the 23rd particles. Okay, if we know we're given 2.11 times 10 to the 24th molecules of sucrose, how many moles is that? Well, we're going to use the conversion factor, and we want to flip it because we want molecules to cross out, we want moles left. Okay, we've done this kind of math and this conversion before, and we will use it again in stoichiometry. Okay, so question: what does the mole measure? Yes, the amount of a substance. Next question: what is the conversion factor for determining the number of moles of a substance from a known number of particles? Answer is very good.